Hi, I'm James, a developer on the Voltron core team. This video will serve as an introductory tutorial for users who are new to the Voltron platform. I'll talk a bit about what the platform is, how it's used, and some of its features. I'll also cover the basic platform installation instructions for Ubuntu, including how to install dependencies, create a copy of the source code, and how to start the platform. Let's get started. Voltron is an open-source, scalable, and distributed platform that seamlessly integrates data, devices, and systems for sensing and control applications. It is built on extensible frameworks, allowing contributors to easily expand the capabilities of the platform to meet their unique use cases. Features are implemented as loosely coupled software components called agents, enabling flexible deployment options and easy customization. Users of Voltron are often deploying the platform for use cases such as an integration hub for connecting a diverse set of devices together through a common interface, low-cost data collection deployable on commodity hardware such as Raspberry Pi or Intel NUC, developing scalable, reusable applications to deploy in the field without spending development resources on operational components not specific to the application, and as a testbed for developing applications for a simulated environment. The platform includes features and frameworks which allow the user to adapt the platform to their use case. Out of the box, Voltron includes a message bus allowing communication between agents on individual platforms and between platform instances in large-scale deployments. Integrated security features enabling the management of secure communication between agents and platform instances. A flexible agent framework of loosely coupled, extensible, and independent software modules on which the platform core functionality is built, and which users can adapt to suit their use case. A configurable driver framework for collecting data from and sending control signals to buildings and devices, which can be extended to support the real devices users have in their buildings. Automatic data capture and retrieval through our Historian framework. An extensible web framework allowing users and services to securely connect to the platform from anywhere, and the capability to interface with simulation engines and applications to evaluate applications prior to their deployment. Now let's get started with the Voltron installation process. This is a brand new virtual machine, so we should update the operating system. Open up a terminal window and run sudo apt-get update. And now we can install the Voltron prerequisites. The command to install the prerequisite packages in Ubuntu is sudo apt-get install build essential lib ffi dev python 3 dev python 3 venv openssl libssl dev libevent dev and Git. If you are using a non-Debian-based system, the package names and package management commands could differ. The Voltron Read the Docs page documents the list of required packages for Debian-based and Red Hat-based systems, as well as how to install them. These packages we're installing include Python and Python's virtual environment package, as well as packages for compiling Python code using SSL and for making use of some operating system features. It may take a few minutes to finish. To install the Voltron platform, we'll need to get a copy of the Voltron source code from GitHub. Git, one of the packages we installed earlier, can be used to make a local copy of a GitHub repository using a command called clone. The Voltron GitHub repository has a number of branches containing different versions of the source code. The main branch contains the most stable release version of the code. If you're interested in having the latest features and bug fixes, you may choose to use the develop branch instead of the main branch. I'll be cloning the Voltron code into my home directory, but if you'd like to install it into another directory, use the cd command to set the present working directory to the target for the clone. To clone the main branch, use the command git clone https://github.com/voltron/voltron. If you have chosen to use the develop branch, include -b develop at the end of the clone command. For this tutorial, I'm just cloning the main branch. Now that we have a copy of the Voltron source code, we'll bootstrap a Python virtual environment. A virtual environment is a tool for isolating system-level libraries required by a specific application or project such as Voltron. This enables users to install multiple applications or projects that require different versions of the same software packages. Voltron can be installed within a virtual environment and provides a utility script, bootstrap.py, to create the virtual environment and install dependencies into it. To run the bootstrap.py script, first change to the Voltron directory by running cd voltron. Then run python 3 bootstrap.py. This downloads all the Python packages required for core Voltron. Because this process is downloading Python libraries and installing them into the virtual environment, it can take a few minutes to complete. This script also provides several options to download additional packages required for different agents or functions. As an example, historian agents often require additional packages for connecting to databases. To install packages for databases, add the --databases option to the bootstrap.py command. At any time, you can run bootstrap.py with the --help option to list all of the options for installing dependencies. After bootstrap.py is finished, you can activate the environment to access the Voltron dependencies and commands. The command to do so is source env/bin/activate. When the virtual environment is activated, the far left of the console should display Voltron in parentheses. Now we're ready to start the platform and test our instance of Voltron. An instance is the term used to indicate one copy of Voltron running on a system. To start the platform, it is really handy to use the command /start Voltron. This command is a shortcut for the command displayed at the bottom of the screen, and will start the platform running and cause it to output a log in very verbose mode, meaning that it outputs a particularly descriptive log. The log file is called voltron.log and can be found in the directory where we've copied the Voltron source code. /start Voltron also starts the platform instance running in the background, which means the user can continue to use their current shell window to input commands. This is very handy since Voltron includes many commands to use various features. Before we move on, I'd like to talk about Voltron Home and running other Voltron instances. Voltron Home is a directory used to store files for an instance of Voltron, such as agent executables, Voltron configuration and authorization files, and more. The default directory for Voltron Home is the .voltron directory in the user's home. Multiple instances can be run from the same copy of the Voltron source code, but each instance must have its own Voltron Home directory. To start a platform instance using a specific Voltron Home, set the Voltron_home environment variable by typing Voltron_home equals, and then the path to the directory such as /opt/Voltron/.voltron2, and then adding this /start Voltron command. The Voltron codebase includes a simple example agent called a listener agent. This agent reads all data published on the Voltron message bus and outputs the contents into the Voltron log file. The agent also generates a periodic heartbeat signal which can be seen in the logs. Installing a listener agent is simple and helpful for seeing how the platform works as it's running. To install our listener agent, we can use vctl install examples/listener agent. We'll add the --tag optional argument with the name listener to add a tag we can use to refer to the agent in commands. Next, let's run our listener agent. We can use the command vctl start --tag listener. Here we use the tag we created before with the start command to tell the platform to start the agent and connect it to the message bus. One very useful command for working with a running Voltron instance is vctl status. vctl is shorthand for Voltron control, and status is used to display the running status of any agents the user has installed. Let's try VCTL status now to see agents installed on our platform instance. The command will output a few fields. First, the short form of the UUID of the installed agent. A UUID is a unique identifier for an agent running on the platform, and the short form consists of a minimal number of characters from the start of the UUID. This string of characters can be used to refer to the agent when using commands such as VCTL start or stop. Next is the agent field, which lists the name of the agent followed by a dash and then the agent's version number. The identity field is used by the platform to refer to an instance of an agent. The tag field is the tag which the user gave to an agent for working with the agent in Voltron commands. Status indicates the running status of an agent. Agents which are not active will have an empty status, and agents which are running should show running status. Finally is the agent health. An agent running as expected will have good health, where an agent which has entered an undesirable state will have bad health. The status output shows that our listener agent is running and is in good health. When in good health, the listener will periodically publish a heartbeat signal to the message bus. We can view this signal by reading the Voltron logs. We can follow along as the Voltron log file is written by using tail-f voltron.log. The examples shown here show the listener agent's heartbeat signal. Now that we've successfully run the platform with the ZeroMQ message bus, it's time to try a RabbitMQ installation. If you're only interested in trying Rabbit, you can skip the ZeroMQ bootstrap instructions and try the RabbitMQ Voltron setup immediately. To convert a running Voltron instance from ZeroMQ to RabbitMQ, first stop the process using /stop Voltron. This shuts down all running agents and then shuts down the platform. RabbitMQ runs on the Erlang programming language, and Voltron includes a utility script for installing Erlang on your Linux system. The Rabbit dependency script is found in the scripts directory, and the user is required to provide one parameter for the base operating system distribution, and a second parameter being the specific version of the installation. This script will install Erlang at the system level, so the user will be required to run the script as root using sudo. For my environment, I'll be using Debian Bionic, Debian being the base distribution for Ubuntu, and Bionic being the codename for Ubuntu version 18.04. Installing Erlang can take a while, so be patient. The command is sudo scripts/rabbit_dependencies.sh Debian Bionic. Now we'll need to make sure our hostname is properly configured. For a single VM running in NAT mode, the hostname is the name of the system. You can find the hostname of your system using the hostname command. Keep this information for later. Next, we'll need to run the bootstrap script again, this time with the --RabbitMQ option to add the required libraries for connecting Voltron to the RabbitMQ server and to install the server itself. The command is python bootstrap.py --RabbitMQ. Now that we have the dependencies, we'll have to tell Voltron to use RabbitMQ. When we started the ZeroMQ-based message bus before, Voltron generated a platform configuration file with some default values. To make Voltron run using Rabbit, we need to change some of the configuration settings. To make this easier, Voltron includes the VCFG or Voltron config command. Using VCFG with --RabbitMQ single, we can configure a single Voltron instance to use RabbitMQ. Running the command will start a wizard, which will ask how the deployment should be set up. Let's go through the wizard for our example platform. The first question is if Voltron Home is currently set to the directory for our instance of Voltron. If this is not your first instance, or you'd like Voltron Home to be in a different location in the file system, answer N for no to this prompt and then run VCFG again. First set Voltron Home to the target directory, such as Voltron 2, then type the command as we've done before. For this basic first-time installation, I'm going to use the default directory, so I'll just answer Y for yes in the prompt. The second option allows us to give this instance a name to make it unique from other instances in the deployment. Next, the wizard asks if the directory in brackets corresponds to the directory that the RabbitMQ server should be in. If you use the RabbitMQ server installed with bootstrap.py, the default directory should be correct, or you may have chosen to use a different directory, in which case you should input that directory to the prompt. For this demonstration, I'll stick to the default, as I did not specify a directory when running the bootstrap script. The wizard will then ask for the fully qualified domain name of the system. Here we should make sure the output from the hostname command we used earlier matches the prompt. RabbitMQ uses X509 SSL certificates for authentication. To enable SSL-based authentication, Rabbit requires a root CA certificate. This may be provided by your organization. However, for our simple example deployment, we're going to allow VCFG to create a new self-signed root CA certificate for us. To do this, we'll need to provide some values for some identifying information for the certificate. In other words, these are part of what distinguishes one certificate from another. For this example, I'll use the US country code, Washington State, PNNL for the location and organization, and Voltron for the organizational unit. You should input values that best describe your deployment. After the CA cert has been created, the prompt will ask you if you'd like to use default values for a few RabbitMQ connection settings. For my deployment, I'll choose to use the defaults. However, if you choose to use different values, the prompt will ask for desired port numbers for HTTP, HTTPS, AMQP, and AMQP using SSL. Finally, the wizard will configure RabbitMQ and start the RabbitMQ server. With configuration completed, we can now try starting the Voltron platform configured with RabbitMQ. Use /start Voltron once again. Our previously installed agents will work seamlessly with RabbitMQ and should not require any changes to run. If we use VCTL status again, we should see that the agent is still installed, although its status and health will be empty until we start it again. Like before, we should be able to start the agent using VCTL start --tag listener and see its healthy running status using VCTL status. We can follow along with the Voltron log file to see that the heartbeat signal is being published to the message bus. That's all there is to installing a basic Voltron platform. As the next steps, you can try the other Voltron tutorials for topics like the Historian Framework tutorial, Driver Framework tutorial, and more. We hope that this video has helped you get started with Voltron, but if you have any questions, you can refer to the Read the Docs, which covers all things Voltron, or ask a question to the community via Stack Overflow or the Voltron Slack channel. We host a bi-weekly office hours meeting via Zoom where we discuss topics like use cases and upcoming releases. To be added to the Slack channel or invited to the office hours, contact us by emailing voltron@pnnl.gov. Thank you for following along with me, and welcome to the Voltron community.